Hello. Hello, guys. Hello. Hi, Luandiswa. I was just waiting for people to join in, and I see people are coming in slow. And I only have 2 people now. But nonetheless, I think I am going to continue with the 2 of you guys, waiting for the others to come in. Let me just check. Martin, are you writing physics today? I heard said Desmond saying you might be writing physics today. Luandi, sir, are you writing physics today?
No, sir.
Okay, Cabello?
Yes,
Cabello?
sir. Yes, sir.
Are you writing
physics today?
All right. No, it's fine. I guess others are busy preparing. That is why they didn't join. But it's fine. We can continue just a few of us. Okay. So, guys, today I chose, since I knew that people are writing physics, I chose something that is more straightforward, something that is simple, and something that is easy to understand. I see other people are joining as well. Okay. I want us to look at formal proof. If you have checked on the extract of the exam guideline that I sent you, you have seen that there are some proofs in Euclidean geometry that are examinable. So those are the ones that I want us to look at. Okay. So I was informed that this group is gonna.
Sorry, sir.
I was in. Hello.
Sorry, sir. Can you please excuse me? I will leave because I'm not in a group of physics. I'm in a group of maths. Sorry to enter here. So I will leave.
All right, but this is maths. Are you also part of maths?
Yes, sir.
Yes, it's fine. Isn't it physics? We're gonna be looking at it around 7 o'clock. So I'll release you at 6:30. Yes.
Okay.
Okay. All right. Okay. So I was talking about the formal proofs. Formal proofs in Euclidean geometry, right? So if you check, if you read the extract, I took a screenshot of the extract from the exam guidelines 2021, which indicated which formal proofs are required. So from whatever that we have done so far, we are going to look at 4 formal proofs. So this is rather straightforward. Guys, where you don't understand, you just have to feel free to ask. I hope you see my board there. Okay. So the first one, the first question, right? We talked about the first theorem, which was saying a line drawn from the center perpendicular to a chord. What does it do? It bisects the chord. Okay. So we have the first one there, number 1, which says use the diagram below to prove the theorem that states that the line drawn from the center of the circle and is perpendicular to the chord, it bisects the chord. So we have our circle there, then we have our chord AB, AC, then we have a line drawn from center and it's perpendicular to the chord, which is O. Okay, so here we are required to prove that, okay, here we are having M1 and 2, okay, we are required to prove that AM is equals to MC, okay. So guys, before you prove, you need to know what are you going to apply in order to prove this, okay. So here what we are going to apply is what we call congruence in triangles. So you are going to apply congruence in triangles, right? What does congruence mean? If you remember very well, congruence means the same in size and in shape, or the same in shape and size, okay. So congruence, which is like an equal sign, that is a third bar, means same in shape and size, right? And if you remember properly, the reasons for proving congruence, we can prove congruence by proving side. We can prove congruence by side, angle, side. We can prove congruence by angle, side. Then we can prove congruence by RHS, if you remember correctly. That is how we can prove congruence. So the proof of this one, of the first one here, uses what? Congruence in triangles. It uses congruence. So I'm going to indicate it here. Congruence. Okay? So the first thing, the first step is construction. Construction, join AO and OC. So construction, when you're constructing, you use dotted lines. You use dotted lines like that. Okay? So if you check, we have 3 triangles, but we have 2 right-angled triangles. So we need to prove that the 2 right-angled triangles are congruent. Okay? So how do we do that? Right? We check. So I've indicated construction there. Join AO and OC. So for the sake of my space, so in triangle AOM and triangle COM. So we have that triangle and that triangle. We can check from the triangles that AO is equals to OC. AO is equals to OC. Who wants to tell me the reason, guys, so that I won't speak alone?
Construction.
AO is equals to... This is what? Yes. The reason, yes, the reason is what? They are radi. Okay? Then we also have another side that is equal. We have...
Sir,
yes?
can you also say the reason for OA is equal to OC? It's because of construction.
You cannot say that it's construction, it's because of construction. Because even if I construct, so if I can construct something like this, then I say D. Does it mean OD is the same as OC? No, it's not because of construction, it's because they are radi. Ne? Because I can construct anything there. So it's not from construction. Unless if I had indicated that construct a OA, which is equals to what? OC. Then here I say OA is equals to OC because of construction. But I didn't indicate it on my construction. Yes. Okay. So then we have OM, which is equals to what? OM. Okay, we see that
Common.
this is what? This is a common. It's a common side. Yes, it's a common. It's a common side. Okay. Then, is there anything else in the two triangles that is equal?
2 and M1.
M1 and M2. Okay. M1 is equals to M2. Why?
We are given.
We are given. Both they are equals to what? 90 degrees. We are given that it's 90 degrees. Okay. So from there, we can note that we can now conclude that therefore triangle AOM is congruent to which triangle? Because now the corresponding angles you have to be on the same what? On the same position. So we would say AO CO M. So it's AOM COM. Okay, so it's triangle AOM is congruent to triangle COM. What is the reason? Because we have a 90 degrees there and we have proved the hypotenuse and a side. We are going to use the reason RHS. That's the reason. Because we have the right angle, we have the hypotenuse, the right angles are equal, we have the hypotenuse that are equal, and we have a common side there. So it's RHS. Okay? So, what do we know about corresponding sides in congruent triangles? Corresponding sides are equal. So, it means that now we can conclude that AM is equals to MC. Remember, I indicated when you start in that congruence means the same or equal in shape and size. Okay, so since OAO is equals to CO, OM is equals to OM, then it means AM is also going to be equals to MC. So the first thing, prove congruence. Then after proving congruence, then you just conclude that these are corresponding sides of congruent triangles. Then the first one you are done. Okay, so number one, it uses congruence. Let's look at the next one. Any questions? All right, I hope not. Right, let's look at the next one. Number two. Unfortunately, those all of them they were AAA, but number two was saying use the diagram below to prove the theorem that states that the angle subtended by a chord of a circle is twice the size of the angle that it subtends at the circle. I mean at the center. Oh, the angle subtended by a chord at the center of a circle, okay, is twice the size of the angle that it subtends at the circle, okay? My diagram is poor there, okay? So we have O, the center, we have A, we have C, we have B. Okay, so from the statement, what are we required to prove? We are required to prove that AOC is equals to 2ABC. That is what we are required to do, to prove. Okay, so the first thing is construction. Okay, right? So our construction here is join BO and extend to D. Okay, join BO and extend to D. Okay, so I'm going to join using a different pen. Right. Right, such that we have D. When it comes to our angles, now at the center we are now having two angles, which is 1 and 2. Also the other side we have two angles, which is what? 1 and 2. Okay, and if you check on our diagram, we have now two triangles. Okay, so the triangles that we are now having, so we are having triangles, triangle A, B, O, and also triangle C, B, O. Okay, right. So this one, it uses exterior angle of a triangle. What do we know about an exterior angle of a triangle? It is equals to the sum of the interior opposite angles. Okay, so we can start in triangle ABO. We see that angle O1, the one that is in red there, is going to be equals to B1 plus A. Why did we say that? Because this is exterior angle of a triangle. Okay, so if I can cover the other side like this, you can see that here we are going to say O1 is equals to B1 plus A. Okay, but what we know about B1 and A, angle B1 is equals to angle A. Why? Because this is what? Angles opposite radii. Okay, or we can say angles opposite equal sides, or angles opposite equal radii, or we can say equal sides equal angles. Okay, because remember that OB is equals to AO. Okay, so what does it mean? It means there that O1 is equals to B1 plus B1. So it's going to be 2B1. Okay, oh, let me just write it, that O1 is equals to B1 plus, now A, we know that is the same as B1, so it's going to be B1. So it means, therefore, angle A1 is equals to 2B1. All right. So again, also on the other side, you know, you no longer need to write the reasons because the reasons are the same. So in triangle CBO, we see that O2 is equals to what? Is equals to B2 plus C. The reason is what? Exterior angle of a triangle. Then also angle B2 is equals to angle C. The reason is what? Angles opposite equal sides. So it means, therefore, O2 is equals to 2B2. Okay, is it understandable, guys? Anyone lost? Oh, silence means we're okay. Okay, so now we have angle A1 being equals to, O1 being equals to 2B1. Then also you have O2 being equals to 2b2. Okay, right? So I'm going to rub on the top there so that I can write on the top using a red. Okay, but what can we see? We can see that angle AOC is made up of what? AOC is made up of what? O1 plus O2. AOC is made up of that angle and that angle. Okay? And O1 is 2B1 plus O2 is 2B2. Factoring out 2 there, this is going to be 2B1 plus B2. Okay? Then B1 plus B2 is A, B, C, right? Which is equals to 2A, B, C. Because A, B, C, the whole angle is made up of B1 and B2. Therefore, AOC is equals to 2AB, ABC. Okay? So, number 2, it uses exterior angle of a triangle. So, you divide into 2, the left side and the right side. Okay? Then you indicate for us O1 is equals to B1 plus A. Then you say the reason. But B1 is equals to A. Why? Because they are angles opposite equal sides. Because remember that OB is equals to OA. These are radii. All right. Any questions, guys? Any questions on this one? Okay. Silence means that you're okay. Is it Luandiswa and Batin?
I'm fine.
You're fine. Batin? Are you with us? Luandiswa, which grade are you in?
Grade 12, but I'm upgrading.
Okay. Batin? All right. No, it's fine. Let's move on. Okay. Right. Then on this one, we actually have 3. Let me just quickly go through the other 2. Right. This is the first one. The second one is like this. The second one is like this. Right. Right. Then it says A, O, C, then B. Right. Then here it says, this is the second one, right? It says prove, required to prove that AOC, this one, the outer one, is equals to 2ADABC. That is B. All right. So this one is actually the same as the first one. This one is the same as the first one. In what sense? You just construct. Your construction is simple. The same there. Construct such that now you have 1, you have 2, you have 1, you have 2. Okay? So again, this is exactly the same as the first one because you're just going to indicate for us that maybe, let me just use O1 is equals to B1 plus A. That is true. That is true. That one plus that one. Okay? Then the reason is exterior angle of a triangle. Then O2 is equals to B2 plus C. Again, exterior angle of a triangle, right? But guys, we know that A and B1 is the same, and also B2 and C is the same, right? Then you can proceed from there. Any questions? Because this one is exactly the same as the first one. Luandiswa,
Question, sir.
do you have questions on this one, or should I do it properly?
Also, I understand it's the same thing, just different diagram.
All right, thank you. All right, but we have another one, the third one, which is in this way, right? Right, this is our O, A, C, then that is our B. Right. This one now becomes a bit complicated. This one is different to the other ones. Right? So, guys, we are required to prove that AOC is equals to 2AB, ABC. That is what we are required to do. Right? So our construction, now you construct again, you join, but here the joining part is now a bit different. Right? You join it from there. Right? Such that if you join, we are going to have the first one, then O1, that is O1, which is that one, and that one. Right? Then we are going to have another one, which is 2. And we are going to have another one, which is 2. Okay? Right? That's how you construct. That's the construction part. So this one, usually it confuses people, but it mustn't confuse you. Okay? So which triangles are we going to focus on? We are going to focus on triangle. The first triangle is going to be triangle AOB. AOB. That's the triangle that we are going to focus on first. Let's check which one is the exterior angle there. It's O1. So in triangle AOB, O1 is equals to B1, the one that is red, plus the other side, which is what? A. Then that is what? Exterior angle of a triangle. Okay? But B1 is equals to A, because there are angles opposite equal sides. Okay? So what does it mean? It means O1 is equals to 2B1. Okay? Then the other triangle that we are going to focus on OCB. Okay? So in triangle OCB, right? We have O2, right? Which is equals to B2, the bigger angle that is in black, plus C. So B2 plus C in OCB, this triangle. Okay, right? Then we know that O2 is going to be 2B2. Okay, so now we have O1, which is equals to 2B2, B1, I mean. Then we have O2, which is equals to 2B2. Okay, right? Then from there, allow me to rub because of my space. From there, when we are given these angles, we are now given, we have O1, let me just write here, O1, which is equals to 2B1, and also O2, which is equals to 2B2. Okay, so now how do we get AOC given these two angles? AOC, right, given this one is going to be the bigger angle minus the smaller what? Smaller angle. So it's going to be O2 minus O1. Okay? O2 minus O1. That is how we get what? AOC. The bigger angle minus the smaller angle. We get this angle. Remember that this one plus that one. Let me write it in red. Let me just indicate in red. This angle plus that angle gives us what? The bigger angle, which is what? Which is O2. So in order to get the one that is in the middle there, we subtract the bigger one minus that, which is O2 minus A1, O1. Okay? But what is O2? O2 is 2B2 minus O1 is 2B1. B2 minus B1. And if we check on top here, B2 minus B1 gives us ABC. So which is 2ABC. So it means therefore AOC is equals to 2ABC. Right? Any questions? Any questions? I think putting it in different colors there, it's actually going to help for people to actually notice how it goes like. Okay? Right? So here it's O2, the one in black, minus O1. We get AOC. Then B2 minus B1 is ABC. Okay? Then we have proved our theorem. Okay? So this is how you do. So this is the other one, the extension of that one, a different case, which is case number 3. Okay, right? So the third one we will look at, it's cyclic quad, right? The cyclic quad number 3. If you go to the questions, they say use the diagram below to prove the theorem that states that opposite angles of a cyclic quad are supplementary. Meaning to say they add up to 180 degrees. B, C, A, D. Then we have O. All right? So what we are required to prove, we are required to prove that angle B plus angle D is equals to 180 degrees. That is what we are required to prove. So this one is simple. It just uses angles at center is equals to 2 times angle at what? At the circumference. So what I do there, construction. My construction, I'm not going to write that I'm constructing, but I'm just going to construct. Join A, O, and OC. such that we have O1 and O2. Okay, so from there you can see that O1 right, let's talk, guys. O1 is equals to, let's talk. O1 is equals to,
is equal to 2b.
equals to 2b. What is the reason?
Angle at center is twice the angle at circumference.
2 times angle at what? Circumference. Okay. Then how about O2?
Is equal to 2d.
2d.
Yes,
Right.
same
And
reason.
the reason is the same, right? Okay.
Yes.
But what we note about O1 plus O2?
In 360 degrees.
360 degrees. Why?
Revolution.
Yes. It's angles around a point. Yes, it's also the same revolution angle. Okay. What do we know? O1 is equals to 2b plus O2 is equals to what? 2d, which is 360 from here, from the top. Okay. So we can factor out what? We can factor out 2, or we can divide across by 2. I love factoring out. B1 plus D. So what do? I divide both sides by 2, such that now I see angle, therefore angle B plus angle D is equals to 360 divided by 2. It's 180 degrees. So number 3 there, it just uses what? Angles at center is equals to 2 times angle at what? Circumference. As simple as that. So O1 and that one, O2 and that one. But we see that these are angles around a what? A point. They add up to 360. So you later substitute them with their equivalent from the other sides. Then you are done. Okay? Right. The last one that we are going to look at today is turn chord. The last one we are going to look at today, it's turn chord. Number 4. From the questions, prove the theorem that states the angle between a tangent and a chord is equal to the angle in the alternate segment. Okay, so we have a circle, then we have a tangent like that, then which goes there, comes there, comes there, then we have center, this O, B, C, A, E, D. Okay, so what are we required to do? We are required to prove that C or E, A, C is equals to C, B, A, right? That is the angle between a chord and a tangent is equals to the angle subtended by the chord in the alternate what? Segment. Okay, so this one it uses 2. Firstly, construction. Right, join A, O to produce maybe D there in the circumference. So you join there. Then you join going towards where you want to prove. Right? So I join going this side. You join going towards where you want to prove. Such that we are now going to have angles 1 and 2. We're going to have angles 1 and 2. So we have B1 and B2. We have A1 and A2. Then we have D this side. We can call it D that side. Okay? So, yeah, what are we going to do? Okay? The first thing that we need to note is that DAC what's angle DAC? What's angle DAC? DAE, I mean. Angle DAE is equals to? Angle DAE is equals to?
Equal to 90 degrees.
It's equals to 90 degrees. Why?
Angle DAE. Isn't it because of 10 radius? No, sir.
Yes.
Oh.
That is correct. Stand perpendicular to radius. Are we together? Turn perpendicular to radius. Do you see that? Okay. So now we can see that our angle, the one that we need, is A1, right? So it means, therefore, A1, the angle that we need, is equals to 90, the whole angle, minus A2. It's going to be 90. We want this one. So it's 90, the whole angle, minus A2. Okay? Right. Let's move on and go to the other side. What is AD? According to properties of an angle, a circle, AD is a diameter. So what can we conclude about ABD? ABD? Let's not forget ABD.
Angle.
ABD is equals to?
90 degrees.
Is equals to 90 degrees. What's the reason?
Angles in a semicircle, sir.
Angles in semicircle. Or angles subtended by the what? The diameter. Right? Remember, we are interested in B1. So, B1 is equals to the 90 degree minus B2. Okay? Then, guys, what can you see, what can you conclude about A2 and B2? A2 and B2? A2 and B2? Guys, these two are equal. A2 and B2 are equal. A2 is equals to B2. Why do we say A2 is equals to B2? Oh. Okay. Angles in same segment. Can you see that? A2 here and B2 there. Their angles, they are subtended by the same chord, which is BD, or the same arc, which is BD there. I mean DC there. So they are angles in the same what? Segment. Do you agree? Luandiswa? Do you agree? Yes.
Yes.
Right. So what does it mean? It means B1 is the same as 90 minus where there was B2. We are going to put what? A2. Because we have proved that B2 is the same as what? A2. So now look here and here. A1 is 90 minus A2. And now B1 is the same as 90 minus what? A2. So we can now conclude that, therefore, angle A1 is equals to angle B1. Angle A1 is equals to angle B1. So we have proved. Because A1 is the same as EAC. And B1 is the same as CBA. So the first thing, guys, here, prove that this one is 90 degrees. Then the angle that we want is 90 minus the angle that we don't want there. Then also prove that here, angle B, which is ABD, is 90 degrees. Then the angle that we want is 90 minus the one that we don't want. But A2 is the same as B2 because they are angles in the what? Same segment. So it means B1 is the same as 90 minus what? A2, which is the same as the first one. So it means they are the same. A1 is equals to B1. That is how we prove what? Tan chord theorem. That is how we prove tan chord theorem. Okay? Any questions on that one? Let's go to the last one. Again, tan chord. So we have a different case when it comes to tan chord. A different case in tan chord comes in this way. Right, we have our tangent there. Say this is A, this is P, right? Then, there we go. Center is here. Then, we have a situation like that. Then that is C, that is B. Right, then this is still tan chord. We are required to prove that APC is equals to CBP. That is what we are required to do. Okay? So again, construction is almost the same. You construct, you draw a diameter first, then you construct going towards where you want to prove. Okay? So this is simple. The construction is going to be in this way. Draw a line joining P and O and producing what? Maybe, let's call this one D through the center. Remember that this is the center, right? Then, isn't it, we want to prove this side, then you construct from there coming that side, such that we now have two angles where we want to prove. 1, 2. 1, 2. Okay? So if you can see, you now see that APC is now divided into P1 and P2. Okay? And CBP is now divided into B1 and B2. Okay? Right. So this one is actually the easier one than the other one, because this one is straightforward. Right? It's straightforward in the sense that DPA is equal to how many degrees? 90 degrees. What is the reason? That is DPA, which is P1. Let's use P1. It's equal to 90 degrees. The reason is what? Tan perpendicular to radius. Okay? Right? And we can also see that B1 is also going to be equal to what? 90. These are angles in semicircle. Okay? Right. Then the other one, we can see that angle P2. Or maybe you can note that P1 is equal to B1, because both are equals to what? Both equals to 90. This one and this one. Okay? Then we can see that P2 is equals to B2. This one and that one. Why? Because they are angles in the same seg, or angles supported by the what? Same chord or the same arc. Right? Then from there we can see that P1 plus P2 is the same as B1 plus B2. Why? Because remember that P1 is 90. 90 plus P2. But P2 is the same as B2. So this is 90 plus P2, 90 plus B2. But P2 is equal to what? B2. So it means these two are equal. Okay? Then it means that APC is equals to CBP. Because this is P1 plus P2, it's APC. Then B1 plus B2, it's CBP. So we have proved that this one is 90, this one is 90. This one is equal to that one. So this one plus that one is equal to that one plus that one. That is simple. So this one is simpler than the first one. Okay? So this is how you prove tan chord theorem. So guys, when it comes to the proofs, these simple proofs, we are done. For those ones who are doing grade 12, we are going to look at other proofs, maybe in similarity and proportionality. We are going to look at them. Otherwise, for today, I think this is enough. We have people who are writing physics in the next 30 minutes, so I have to release you early so that you can prepare, guys. If there are any questions, you can ask now. Otherwise, I don't think there are any questions. Please comment with any word that you got from the lesson until we meet again next time. Thank you very much. Good night.